Hi, my name is Giancarlo Paternoster, and this is a video explaining my homemade drum sander. So this whole machine is based off of a 240 volt circuit, which I have wired to all the machines in my shop. And it runs off of a 240 volt air compressor duty motor that I bought from the Harbor Freight. It's rated for 3 horsepower, and I really haven't had a problem with the kind of power output that it has. It runs on a small little pulley here that I bought from the hardware store, and I made my own pulley here on the top using the table saw and kind of just by tilting the blade and cutting in a little V groove. And the belt I think is from like just a Tractor Supply thing. I just bought the belt one that would fit. The belt tensioner is on here with a door spring, and it's riding on skateboard bearings, and essentially it just has I think it's a number 29 spring on there that kind of just keeps everything nice and tight on the non-drive side, so when it's turning around it kind of just keeps the noise down and the vibrations low on the machine. So there are 2 dust collection ports on the back, and they accept a 4-inch wide hose. I run a Y connector here up to my normal, I have a Harbor Freight model 2 horsepower shop dust collector, and I have not had a single problem with the amount of dust. You guys will see later in the video that there really isn't much dust that gets kicked up by this machine that's not sucked up by the dust collectors. So that's what I do for dust collection. This big shroud comes off with 3 screws to reveal the drum. Set this aside. So here's the drum. You can see here the reason why I'm making this video is because I'm actually going to change the paper. I was doing something and forgot what paper I had on there and put 2 nice big burn marks on there. The paper goes on with hook and loop, but also gets 2 screws on either side of the paper to hold it in. And the paper I buy from a USA sanding supply store, and the hook and loop stuff I got from the Home Depot. I actually think it's Velcro brand. The drum is 6 inches in diameter, and it's made up of 40 3/4 inch thick MDF discs that I cut out on the drill press using a big 6-inch hole saw, and they're all kind of laminated together. The shaft is a high precision shaft I bought on Amazon, and I don't remember, I think it cost me less than 50 bucks, and it is it's 40 inches long. So the 1-inch diameter shaft runs on 2 pillow bearings. These are really good for keeping things aligned, especially when you're kind of tweaking it to get your final setup done and making sure that everything is parallel and straight. The frame on the outside, so there are 2 pieces that are exactly identical, are constructed using finger joints, and the wood I use for this is just construction grade 2x4s that I bought at the Home Depot. The table's made up of 2 sheets of 3/4 inch birch plywood. It's a torsion box construction, which essentially just means that there are runners this way and spacers running this way that keep this whole thing really flat. So the mechanism that I use to lower and raise the table is very, very simple. There are 2 stainless steel door hinges, which were pretty heavy construction, that I also bought at the Home Depot. In the back here, and they're kind of hard to see, but they rest on a rail, and this whole table pivots on those 2 hinges. Then there's a 5/8 inch threaded rod here with a nut and a wheel pressed onto it, which is kind of just like a faux machinist's handle. And it rides up on this steel track up here just so that I don't really scrape up this bottom plywood piece. And when you turn it up and down, it changes the height of the table. And it rides up and comes back down. So as you can see here, I have a little computer box. On the bottom is mounted a voltmeter and an ammeter combination that tells me the current and the voltage to the unit. And then on the top here you have something that's kind of interesting, which I thought is pretty necessary just to tell if the machine's being bogged down, or just to make sure that the rotational speed of the drum is what it should be. This little computer here tells me the rotational speed of the drum based on the blips it's getting from this little Hall effect sensor here that reads. There's a magnet under this blue strip of tape in this pulley, which is the same diameter as the outside of the drum. Every single time it passes, the Hall effect sensor sends a little blip to the computer registering that it's moving at a certain speed, and you can actually see there that it's changing a little. So this is an off-cut of a bottom of a big 6-drawer dresser I did a couple of months ago, and you can see here none of the boards, well, I guess you can't really see, but take it from me, none of these boards are actually flat or flush together, and there actually still is a little bit of glue that needs to be cleaned up, so I'm just going to run this through just to give you guys an idea of what this machine can handle. So as you can see, we probably took just about a 1/16 of an inch off of the thickness of this piece of material, and now it is completely flush, and that little glue line that was here is now gone.